Hello, everyone. I'm Harvey Rook, developer on Exchange Web Services.
And I'm Naveen Chan. I'm the PM lead on Exchange Web Services. So today we're going to be talking to you about an overview of Exchange Web Services and some of the best practices that we have for using them. So with that, we'll cover kind of what is Exchange Web Services. We'll talk about schema versions, which is really a big selling point for Exchange Web Services in that it offers applications the ability to do backwards compatibility. So as future versions of Exchange get released, your applications still continue to work. We'll talk a little bit about the Exchange Managed API and how that's great for improving your development experience using EWS. Then we'll get into some of the nuts and bolts, and Harvey will talk about user agents, IIS logs. We'll talk about some of the authentication, authorization, auto-discover, and throttling pieces as well. So with that, let's go ahead and get started. So extensibility for Exchange has had a long and windy and rich journey, a little bit too rich in some ways. We've had many APIs that have been introduced for Exchange, some of which have been taken away. But starting in 2007, we really standardized along the web services route. And so we're ensuring that we have a standardized programming model so that developers that go and do investments in extending against Exchange have one consistent way to go and do that. And so combined with auto-discover, this gives you a very powerful way to go and extend Exchange. Auto-discover is the ability for you to specify an email address and credentials and then go and find out the endpoint with which to connect into. So we use a standards-based API. Once you have that endpoint, you can use standard APIs to connect and look at things such as email, calendar, contacts, and task information. And then using that type of data, you can actually get access to it. Contrasting with something like Mappy that we have. So if you've been working with Exchange for a while, you're familiar with Mappy. EWS is more of an action-oriented API. And so what that means is if you're doing things like creating a meeting invite, you would write a command to create the meeting invite. It would automatically send the mail, and on the server take care of things like acceptances and updating that status. Versus if you were doing this in the Mappy world, you would have to keep track of all the properties, ensuring that everything was set correctly. And as you can imagine, for things like recurrences, where you have a bunch of updates that are done to a meeting, keeping track of that can get very cumbersome very quickly. And so EWS provides great benefits in your ability to do this and easily develop against Exchange. One of the other things that EWS provides is a great notification and synchronization mechanism. So there's a couple of different ways of doing notifications. And we'll talk a little bit about those. It's mostly a stateless API. And what that means is your request can land on any front end for most of the types of requests. And they'll get proxied over. Though we do recommend that you keep cookie information and replay against the same server. That'll ensure that you have optimal performance rather than having to go and proxy from one location to another. In addition to that, in addition to doing the proxy work, you can also, ensuring that it's much simpler. So it's mostly a stateless API that I talked about. Your load balancer settings will work through that, uses HTTPS, SSL, and so as long as you can really marshal, unmarshal XML, and you can use SOAP, you should be able to use Exchange Web Services. So we're platform agnostic, and if you're developing on .NET, we highly recommend you use the Managed API. The Managed API makes development much simpler. For example, it's a lot less lines of code for you to debug, and it also contains the majority of the functionality that's exposed through the SOAP API. We also have a Java version of the Managed API, though that Java version is released on a less frequent cadence. It's open source, though, so we allow communities to go and develop and customize that for their specific needs. So whether you're building a client for PHP, Java, or .NET, you can, as long as you can post XML and process HTTP requests, you can use EWS. If we don't have a managed API for the specific platform that you're developing against, you can also use auto-generated proxies to actually go and work against that environment. So when we look at EWS, we kind of notice that we have three broad sets of different customers. The first of which are those that build client applications. So for client applications, example, within Microsoft, Outlook, for some of its functionality, uses Exchange Web Services. We also have Outlook for Mac, which is built primarily on Exchange Web Services, and that's the only way that it connects against the server. And we also have applications such as Link that retrieve free busy information from Exchange using Exchange Web Services. Portal applications, which is another class of developers that we see. Examples of these would be things like universities, where they are looking at setting up resources, maybe a projector or something, and they want to expose free busy types of information. So they extend the portal using Exchange Web Services to expose that. And the third bucket is really around service applications. And so, for example, CRM applications, where they contain a lot of information about customers, you can use a background job to go and extend into Exchange and correlate data between your two systems. So using something called application impersonation, for example, in the scenario where you have a CRM system with a lot of data around your customer information and user's mailbox that contains contact information for those same customer bases, you can have background jobs that are sitting there being executed and continuously updating based off of information that's changed in your CRM system. So when that user logs into Outlook, they're able to go and see all the updates that have been made through the CRM system. Do you guys have any questions on any of that to start? No? Okay, so I'll switch gears and turn it over to Harvey, where he'll go into some managing of the EWS features. Can you guys all hear him? Sorry, I think Mike. It is.
Hello? Okay, I just have to button up a little bit. Oh, whatever. Schema version. It's not going to work. One more try. My neck is too long relative to my shirt. How's that? Okay. Schema versions. Every new release of Exchange comes with a new set of features and a new functional API to get access to it. Schema, the XML schema or the WSDL file is how you can manage what features are turned on a particular request, or if you need bug-for-bug compatibility all the way back to 2007. You can use the Exchange 2007 version of the feature against version of the schema against Exchange 2013. Just want to go back. Most, depending on what you want to do, for example, we're adding more features every year or with every release. We're into e-discovery, persona, unified contact store, retention policies, user photos, and app management in 2013. If you don't need that, you can feel free to, say, use Exchange 2007 SP1 schema. You'll have to think through what version of Exchange server, on-prem or in the cloud, you want your app to work against, and choicefully choose the schema in your app. We always request a specific schema version. The no schema version means that we, the developers in Microsoft, get to pick what sort of version your app responds to, and we're not always good at that. In the data centers, Exchange 2013 supports schemas all the way back to Exchange 2007. If you're writing an app that our customers, that's running on-prem, for example, you probably won't, you may or may not have access to Exchange 2013. So be careful, again, be thoughtful about the schema that you choose. Make sure that your customers can support that version of the schema. Also, mailboxes move around. A mailbox that was on Exchange 2013 today could be on Exchange 2007 tomorrow. Our administrators are always free to move mailboxes from server to server, and we can't control that. So you'll have to be careful there. A little bit on our managed API. We're really pushing the managed API. Now, EWS is a fully SOAP compliant XML-based protocol. If you can call HTTPS from your platform, then you can contact EWS. The sample you see here is just how to get all properties for the inbox folder, a call that should work against any mailbox anywhere. There's no client-side logic here, so your app should be safe against different builds of Exchange. But you'll notice that there has to be a lot of manual plumbing. This XML is fairly complicated. If you make any twisty little mistake, forget a slash, you'll get some obscure XML error back from our parser and not a lot of guidance on how to debug it. The next step up the ladder on productivity-wise and resilience-wise is the auto-generated proxies. Every Exchange server publishes its WSDL, from which you can generate a client-based or client-side SOAP proxy. This is all multi-platform. It's a lot simpler than the XML in that you get strong types, but you'll notice that every minor action and interaction, for example, if you want to get the inbox, you have to create the folder type, and you have to get the distinguished folder ID, turn it into a type, and bind it all together, and then send the message off. And finally, if you get a success, then you can cast the result as the folder type. So it's type safe. It makes you more productive and more compiler safe. But it still has a fair amount of legroom before you can get a result. Then the managed API hides all the magic from you. If you want a folder, it gets the folder for you, returns it in a typed object. It's very simple, straightforward. Now, do many of you have experience with the managed API? Yes? No? Okay. The managed API, it's increased productivity for you. And on our side, it ensures that your queries are more likely to be well-formed, so there's less debugging on our side or on your side. A few best practices around the EWS managed API. It's a redistributable. You can get it directly from MSDN. You can ship it royalty-free as part of your installer. It's very straightforward to set up and deploy. Now, the requirement is .NET 3.5, which can be a bit of a pain in the ass for some apps. But outside of that, it supports Xcopy deployment. It's a strict wrapper around the EWS XML protocol. It's not like it calls a secret other protocol that's not EWS. So one other additional way to use the managed API then is to say if you want to call EWS from PHP, you can use the managed API on .NET to generate sample XML, so you can learn the details of a query or a post, and then have the PHP server just replicate that call. It simplifies your investigations there. It's also, EWS Managed API is fully object-oriented. If I go back to the examples, and they won't show up well, will they? Oops. The idioms and verbs that we use are the kind of things that you would use if you were calling Exchange, whereas the client-side proxies, you're subject to the whims of the WSDL compiler and the idioms it uses to generate a post. And of course, if you're going to use raw SOAP, then whatever your HTTP request package is. So the references around the managed API are just that much more rich and that much more reliable. Did I just skip over tracing? Yes. The EWS Managed API also has a built-in tracing mechanism, which is useful not only for you if you're debugging your apps, but it allows us to get a sort of well-known trace if you're working with Microsoft and running into a problem against the server. You can carefully choose what you want to be traced. It's not on all the time, but it is available to you. The managed API is not thread safe. Please use one of the service objects for every thread. I would say one great model for scale out is one user per thread per service object. If you're writing a client, a sort of mail client, that's probably not useful for you. But if you're writing a large server-to-server service, those kind of operations will come up far more often. We also, regrettably, we don't expose a completely asynchronous interface in the managed API. There are a few asynchronous operations in the 2013 release. As our partners demand more and more scale, we're slowly converting our operations to async, but it's not all there yet. Now a little bit about user agents and IIS logs. Please, when you write an app, choose a custom user agent string. As your app becomes more popular, the administrators or Microsoft, if your app is running against the service, we need to have great insight, optics, and management tools around particular apps. If you use the default application string, then all we know is that you're part of the great mass of apps, and there's nothing special that we can do to provision or manage you. For example, in some cases, administrators can allow or block a particular user agent string. That's not in some cases, in all cases. This blog gives definitions on, or gives instructions on how to do so. The advantage is then to the customer. They know that they have more control over what apps are running on their servers if you have a custom user agent string. Also in the data center, we don't block per apps in the data center, but it allows us to get extra insight on the kind of operations, the kind of performance that a certain class of app needs, so that as we do our performance budgeting, we just don't lump a particular app in with the generic app requests. And finally, for you, if you're ever investigating or working against production Exchange servers and you see the logs, having a unique user agent string allows you to quickly pick out the requests that your app is making. And in an environment where 30 to 1,000 requests can be happening every second on a particular array of servers, that's very useful. The apps, the user agent string in the logs include lots of useful information. The user that made the call, the type of call that was being made, the number of expensive operations, for example, LDAP operations or local RPCs or store RPCs. Can give you great insight into why a particular operation was fast or slow or what was going on at the same time. One other, I wish I could give you an example. We also have a header, an HTTP header called the request ID. This is just a GUID. This request ID allows us to track a particular EWS call across our servers worldwide. So if you have an app or a service, you issue call GUID 4. We would trace that GUID on every server that request goes through. So if there's ever any broad investigation or any bugs being investigated with the app, we can quickly collect the data related to a transaction no matter where it is in the world or the region. Record this header in your application logging for reference with Microsoft support. I can't tell you how often a multi-week investigation turned into a 5-minute investigation because our partner could provide us the request ID. It just simplifies things lots, orders of magnitude. Authentication and authorization. EWS uses the standard IIS methods for authorization. So if you're experienced with IIS, there's not a lot new there. Now, authorization is where we start to become a little bit different. EWS supports 3 modes. Direct logon. This is where the user has the username and password and directly accesses his or her mailbox. Delegate access. The examples here are, say, somebody and the administrator. The administrator has, say, access to somebody's calendar, or say a conference room where multiple people have access to the conference room calendar. And third mode is exchange impersonation, where our server-to-services kind of operations happen. We see this being used a lot more in the data center. If you want to, say, give your app access to 1,000 mailboxes, rather than touching each mailbox and modifying the security descriptor to give access to your app, you can use the RBAC commands to assign the application role to those mailboxes, and now your app will have access to those mailboxes. Great details here. It's an example of direct logon. Pretty boring. I'm just getting all properties. The important point here is that it's the default. If you don't go out of the way, you will only have access to the local user's mailbox. So, that's either you or whoever's username and password you have. Delegate access. A little bit more detailing needed. Now, the important point with delegate access is that delegates may not have access to all the contents of the target mailbox. I can say provision things so that my delegate only has access to my calendar and my inbox. So the delegate information has to be provided per folder. And then this is exchange impersonation. App impersonation gives the app full access to the mailbox. So you just have to specify the impersonating info in the SOAP headers, and then whatever happens in the SOAP body just works against that target mailbox. Some more details about exchange impersonation. We're seeing it used a lot more in the service. Let's see here, what do I want to say? Okay. This is where your app would be running. Your app accesses the back end. You've pre-configured application impersonation. And so now whenever John interacts with your app is free to go all the way to the back end and interact with John's data. You need not ask John for his username and password on every connection, right? If you have some sort of valid auth there, you don't have to go back and constantly prompt him. Best practices for Exchange impersonation. This only applies to EWS. If you're looking for a way to delegate access to Outlook users or to POP or to OA, this won't work for you. There are other delegate access mechanisms for Outlook, OA, and MAPI, but they're a little bit more futzy and covered elsewhere. For service accounts, impersonation is definitely the way to go. You won't have to administrate the hundreds or thousands of mailboxes that your app will eventually have to access or to interact with. So the administration touch points are just way lower. You can configure it through RBAC and PowerShell. So you can audit what your app has access to, and the administrator can just run scripts to make it happen, as opposed to regular delegate access, which is a little bit more manual. Auto-discover.
Auto-discover. So auto-discover. So with that, we'll start talking about auto-discover and how it can be used. I think you heard a little bit about this in the previous presentation as well, where they were really being the mantra, use auto-discover, especially when connecting to the service. So with that, let's get into it. Auto-discover, as you guys know, when you buy a new phone, you go and you type in your email address, your credentials, and somehow it magically goes and figures out what that endpoint is. Well, this is the magic. Basically, there's a published algorithm that specifies ways to take the SMTP address and run some permutations to try to come up with what that URL would look like. It then, once the URL is found, it tries to authenticate against it and receives back an XML file that indicates this is all the settings that you need to connect up for this user, including the EWS entry point. We have two specific flavors. One, in 2007, we rolled out something called the plain old XML one, and it was largely for Outlook. Contains a huge collection of all the properties that are needed, and it's kind of a one-shot stop. You basically send up the request and receive this huge payload down. In 2010, we built a SOAP XML version, which is the more preferred way of doing this now moving forward. You ask for the specific set of properties that you want to get returned back, and the protocol returns that back down for you. So it's definitely the way to go for the auto-discover endpoint. One of the other benefits of the managed API, this auto-discover algorithm is a little complicated, and so implementing it yourself, it can be a little bit more challenging, but the managed API wraps it, and so it's basically a single line call in the managed API to get access to your full auto-discover. One of the benefits for like large customer deployments is you don't have to hardwire where a specific mailbox is located. You can auto-discover up, so whether your customer is located on-premise, if they have something in the cloud, or they're in a hybrid deployment, and some of their users are local, some of them are in the service, you can use auto-discover consistently across both of those to retrieve back the settings and discover the exact endpoint that you should be connecting up to. Also, one of the things, so now with our high availability model, where a mailbox can be located in multiple different places and the active copy may fail over from one side to the next, it's really a requirement when you're working in the services space and even with some of the newer versions on premise to ensure that your apps continue to work by using auto-discover. So what are the times that you should use auto-discover? Definitely when you're initially connecting up for initial account provisioning, because you have to figure out where the user's endpoint is. But there's also times when you're making requests using EWS and you'll receive back an error response indicating that you should rerun auto-discover. And that basically, if a mailbox fails over, there's a finite set of errors that can be returned, and some of those mean that an auto-discover request should be reinitiated. So you should run it then. Auto-discover, however, is an expensive call, and in the data center can take at times up to 10 seconds to return back results. And so it's not recommended that you run this on every single request, but rather you run it once every 24 hours, cache the results, and you keep using those same results. If you hit an error response, then you can go and re-auto-discover again. So we talked about this. It uses a SOAP endpoint for auto-discover. That's the one that we were suggesting, definitely, because it returns back that smaller set. One of the things, and there's some steps here on how to show you how to tell if the SOAP endpoint is configured properly. One of the things that I want to call out here is don't assume that just because all the mailboxes are in the same domain, they have the same EWS URL. Especially for tenants, we're distributed across multiple different servers. For some larger customers as well, they're even in different sites. And so this really needs to be performed on a per user basis. It's true also when you use application impersonation. We've had some instances in which partners connect in and they use application impersonation with the system account. And they use that system account to auto-discover against, and then start issuing subsequent calls against that system account's EWS endpoint. And that adds to latencies because what it does is it proxies in the back end. So what the recommended pattern is you use application impersonation to authenticate, but then request the auto-discover URL for the user that you're actually functioning as and keep that cached, as we mentioned. That'll ensure that you get optimal performance. The auto-discover algorithm, so one other thing I want to talk about is auto-discover algorithm, which is published, one of the first calls is to look at an SCP endpoint up in Active Directory. And in Office 365, that call is going to fail because your apps don't have access to the Active Directory. So in the managed API, there's actually a flag you can use to skip that portion of the auto-discover to ensure that you get a faster response through auto-discover. Do you guys have any questions on that piece? No? Sure. And I think this deck will be made available as well.
No questions? I can go on for hours about auto-discover. So. Resource protection and throttling. The feature that everybody hates. We run servers with thousands of mailboxes on a particular server, and we have to assume that a particular mailbox will act reasonably. We cannot allow one particular client to say take up 10,000 ROPS and starve all the other mailboxes on that server. And the technology we use to maintain that balance is called throttling. Every protocol, EWS, all of them really, have their own throttling limits. We measure in terms of how much time in CPU or a particular user is spending on this server or querying the AD or hitting the back-end databases. And we try to ensure that every user has a fair share. We're very paranoid about that, so it's not possible for a Office 360, a tenant admin to modify the policies. They can tighten up the policies and make the life painful for apps, more painful for apps, but they can't loosen them. We have a few additional limits in EWS proper. Search find count limits, for example. Searches can be expensive, so we limit how rapidly you can do them. Subscriptions accrue resources, so we limit the number of subscriptions. EWS max concurrency, the maximum number of simultaneous HTTP requests that mailbox can service. And then these are a little bit more self-explanatory. These are the error codes that get returned when you get throttled. If your app is soaking up too much CPU on a particular user, you'll get one of these errors, or an HTTP busy. The app is then expected to back off, sleep a little, and retry in a bit. Now, all is not lost. We don't want to throttle your app into oblivion. The important thing to remember is that these limits are per mailbox, per app per mailbox. If your app needs a high throughput rate, the way around it is to access multiple different mailboxes at the same time. These resources can then be sort of safely processed by separate servers. Right? If you access, if the app only accesses resources for one mailbox at a time and really pounds the server for that one mailbox, then that one mailbox will be starved of resources and your app will be throttled. But if you, say, issue 10 simultaneous queries or 10 simultaneous operations for 10 different mailboxes at a time, then each of them will probably flow through safely. It scales out much better for the service, and your app just has a much better, higher performance experience. This is just a definition change. We reduced the number of subscriptions from 5,000 to 20 in 2013. Our data suggests that nobody has more than 20 devices on one mailbox at a go, or 20 apps on one mailbox, so that's probably shouldn't impact you. Some best practices. Test against the defaults for Exchange 2013 or Office 365. Test and test again. Yeah. Don't require your app to change the, don't require administrators to change the throttling policy to have your app run. As I mentioned earlier, administrators can't loosen the throttling policy in Office 365. So that will be a bad experience for your app if that's a requirement of deployment. The throttling policies, I went over that a little bit earlier. Please ask me questions about that. The nuances of every particular policy setting can be tedious and not generally interesting, but I can explain at length if you have specific questions. Here's a rule of thumb. We kind of provision mailboxes to sort of act like a normal syncing client. If your app acts like a normal synchronous client, then you probably won't notice a thing. But if the more you step out of that model, the more your app will be throttled, right? If you consume, if say you modify 1,000 items, within a minute, which is something users do very rarely, then those kind of operations would be throttled more regularly. Some great references on AWS in the SDK and the managed API and some online articles. Cool.
So that's what we had for the intro. If you guys have any questions, please feel free.
Yes. You're letting us off easy.
Questions? What's that?
Go ahead.
So if you have one, you can ask a couple now.
Any idea what percentage of sites have EWS turned on, of the on-premise sites have EWS turned on outside the firewall compared to ActiveSync, for example?
I think that it's probably the same percentage in terms of ActiveSync. I don't have numbers about that in my head right now. Many features just don't work well. For example, Outlook outside the firewall uses EWS to get FreeBusy and to do some calendaring operations. So we strongly encourage all of our customers to just enable if you're going to have outside the firewall access, enable EWS with it. There's really no security. If you enable Outlook outside the firewall, you're allowing your data outside the firewall. So EWS is not a substantially different security risk. Most customers are fine with that. That wasn't helpful, but vague.
Any idea how many have Auto Discover turned on outside the firewall?
In terms of absolute numbers, I don't have that. But again, by the time you get to 2010, and especially with 2015, Outlook is not possible to configure reliably unless you do it through Auto Discover. So anybody who doesn't have Auto Discover enabled outside the firewall is asking for high support costs.
For the authentication methods, any plans to include something like OAuth in the future?
Yes, but I can't confirm or deny that. What I mean is, internally we're already using OAuth. It needs to go through usability paths before it could be turned on.
And finally, does Exchange impersonation require Kerberos?
No. Any authentication method that you use to talk to the server will work for application impersonation.
Any other questions? All right. Thank you very much.